Make sure your stuff's working there. We got 3 tries. We'll see what happens. We have 3 things attempting to record this. Though, if it doesn't work out, I'll just record this at home. Just do a redo. I did that for New Orleans, just to have a copy. Though this isn't like groundbreaking stuff here. This is walking through how to build a Python processor for NiFi, which is our new way to add extension. Give them 1 minute. Is it 20? Are we there yet? We can start now? Okay. So if you're not here for the NiFi track, you're in the wrong room. Give you a second to run away. This is me. You can connect to me with a lot of different stuff. I'll make sure all the slides are available to people in case you're interested or want to see more of the examples. I've got a ton of example code. You get that on GitHub. There's articles around them. Lots of fun stuff. I do a weekly newsletter, covers a lot of Apache stuff and some other stuff going on in AI and all the fun stuff out there in the world, or at least stuff I like. And cats. There's some cats here. You will see cat pictures. So, just a level set. Have people used NiFi or have heard of it? Probably. Maybe. Not at all. Okay. So I'll show you, and I'll do a lot of demo here. So I'll be in the environment to show you around NiFi and where we put our processors. But just to give you an idea, because there are so many Apache projects that work with data, NiFi is a little different. It was originally open sourced out of the NSA, and they used it for some very interesting data movement. But there's some unique capabilities in here that make it very interesting to a lot of different people, whether that's in enterprise tech, hobbyists, whatever, just because of some of the features. All the demos are running off my laptop, and you could do some, serious running of projects right from a small laptop or old computer. We also have a smaller version of the project that you could deploy to a Raspberry Pi or a smaller device. I'm not covering that one today. That is a really interesting project, though, because you can run it and, put it wherever you have data that maybe can't push to you or you can't access. So having NiFi there, we could push that data out. So NiFi has a couple of features that make it very attractive for doing a lot of different data movement, ETL, ingest sort of things. Guaranteed delivery of your data, and I'll show you some of the unique features there. To be able to dial different levels of data buffering, whether it's back pressure or controlling how much data goes through pipes and being able to do that visually. And the unique thing with NiFi is everything you see on the screen when I show you that, you could do with a REST endpoint. So there are some people like to program without using the UI, which is kind of crazy because the real value is drag and drop, but you don't have to. Being able to prioritize things as easy as just doing a click and changing some settings. So you could have one pipeline that does your standard pick up a file from S3, convert it, drop it in a database, and then allow for emergency records to bypass that with priority queuing just by changing a single parameter is very helpful. Being able to adjust latency depending on how fast you want to try to push your data through. It is extremely scalable. At previous instances, we've had up to 1,000 or more servers. I've got a committer watching me in the room. And that scaled up to 1 billion rows a second. So you could do it hobbyist, move a few thousand on your laptop, or you could be an enterprise and push millions of rows a second without too much trouble there. And then with the versions running on Kubernetes, obviously you could size up, size down real easy. This is the feature that has been really awesome, and I really love this one, the data provenance. Even work? Yeah, laser might not be working. That is a lineage of everything that happens. This is really great for auditing. So if I touch a piece of data, I have all the metadata of what I touched. I changed it when for each step in your process, and that data is first class metadata. I can push that somewhere and store it forever, or I could use it dynamically to work with my data. So I could look at the metadata about my data and add that to my data, which gets a little crazy of like what's data, what's metadata, but lots of different processors out there. We're going to show you how to build your own in Python. So it makes it very easy to extend the product because you'll say, well, sure, you got a couple hundred things you could read from, but I've got some weird thing I made in my house. How are you going to connect to that? Well, there's a ton of different ways if there's any kind of driver out there. With the fact we now support Python, before you had to write them in Java, which, there's not every library in the world for Java, and you got to use Maven and compile it. A lot of work. Here, simple template. You put your code in pretty much one or two sections, use any Python library you want, and now you can start adding functionality. I'll show you some of the ones that I've done to give you an idea. The latest version, unless someone pushed it while I wasn't looking, is 2.5, which I'm running here on a laptop. This is the one that supports Python very well, supports later versions of Java, has all the cool features in it, and it gets a ton of new processors that the community or the main committers are working on that lets you use a lot of modern data systems to get data in and do things pretty performantly. And that includes unstructured data. Again, something that differentiates NiFi from some of the other tools. I can use NiFi with very structured data, semi-structured data, and also extremely unstructured data. And one of the examples, I'm processing images. And that could be in the same path as a JSON file coming through, or XML, or RSS, or a video. You can grab stuff right off of Slack, push it into Discord, read it from Twitter, grab it from Blue Sky, read RSS, MP3s, HTML, output PDF. This has become extremely useful in the last couple of years because of the two-letter word that everyone is adding to everything. This makes it very easy for you to grab documents, apply any kind of vectorization or tools you have to break them apart, and do all that pretty straightforward. So in this part, I'm just going to show you very quickly some of the code here for the simplest possible processor. This is what you'd write if you want to write your own Python processor. It is literally a requirements.txt and a one Python script. You have a couple of imports, and the way we set up the class here, you have your dependencies. These are all the things you'd need to pip install, a description, a version, name of your processor, and this is pretty much it. There's not much in it. There's an init where if you need to initialize stuff, you can put it there, and then the main body of what are you going to do. And when we show you NiFi, this will make sense, what's coming in and what's going out. In this one, we just return a couple of attributes. Attributes are where that metadata lives. So you can take a piece of data, not change it at all, but add an envelope of attributes around it. So if I have data like, I'm not allowed to change this data, but I can add all this metadata to it, pass it through the system, and push that original unchanged data somewhere, but then I could pull off all those attributes and turn them into their own data and push that as a valuable metadata. What that would be useful for is sometimes I'll pull in an image, pull out all the metadata, turn it into a real-time object because I'll call, image captioning on it, or some other AI, get that data and all the text description of that data and push that into a regular database table, or into HBase or Cassandra, or wherever you want to store it. Anywhere, pretty much most of the Apache projects that you could store stuff, we can send it to them. And we'll go through a bunch of examples. I'll do this really quick. This is for you to take away, but we have, I'll walk through the real stuff, but just to give you an idea how simple it is. Take some code. If you have any Python script now that uses some library, does something, it's very easy to wrap it and put it into NiFi. My test one, which I didn't write, I had Cursor AI write it for me because it's pretty simple to write. I'm like, let's see if it could do it, and it did it. The rest of them I wrote, but just to be a full disclosure, AI wrote this one processor. It is very simple. So, I mean, it's not like it did not cure cancer. And I'll show you these other ones of mine. One to do captioning of images, one to do ResNet 50. Again, you can imagine where I got these libraries. This is not rocket science here. There's a couple of them. I'll show you these running, but if you want to see the information on them, those will be in the slides, which I already put up into GitHub. There's a bunch of them. It's pretty much, if there's a Python library, I can call it. But let's see it actually working. So let's go to NiFi. I have it running on my laptop. So the first one I wanted to test is that unstructured data. So I have my own Slack channel here, and I have NiFi as a listener to Slack. So I can send text, whatever, like, where am I? And we'll get that. Or I can add an image. So I'll upload probably a cat image, because I have a lot of those. And this will upload, and when it's done uploading, I have a receiver here in NiFi, and that is pretty straightforward to do. It is one of these processors I told you about. You set this up in a Slack app, and you set up your tokens here, and I have this set up to receive message events and get the user thing, so when that data comes through, it's going to grab it. And I mentioned that data provenance or lineage. This is your UI to it. This data is also available, again, like everything in NiFi, is a REST endpoint, which is pretty cool because you could see all the calls. Like, okay, let me look at the data provenance, and then you could see these calls that it made and what it got back. And you, like, if you want to write your own version of the screen via, curl, you could, because you could see all of them in there. Like, here's the provenance. It's just making a call for the provenance API, and the API is fully documented. But most people want to see it in the UI because it's a little easier to develop with the UI as opposed to doing a lot of curls. There is a command line interface too, but if you have a drag and drop tool, you really want to do the command line version. Some people do. I mean, for automation. For automation, though, it makes more sense. Develop your code, put it into Git, and we have tools that will automate you moving it out of Git into various deployments. So you can write it on your laptop and then deploy it to a server somewhere, which is pretty easy. So this is the event that happened when that came in from Slack. And you could see all the different metadata we got around it. A unique ID for every, what we call a flow file, a file going through the system, is how we represent the data coming in. So this is the JSON we retrieve from Slack. And, just a little bit of metadata, unique name where it came in, but also the content, its size, all that kind of information is great for debugging. And this is the file that we get from Slack. And it includes a lot of metadata. It also includes a link to that image. So I got that data and I check it. There's a couple of fields I want. We can use JSON path, which if you haven't seen JSON path, is a really cool library for extracting JSON using something similar to XPath. It's not bad. Here, it's pretty straightforward. It's just a $sign and a dot and the name of the field. And if it's an array, grab the first one. great way to just make it simpler because I don't want all the data. And remember I said I don't want to change the data often. I just want to grab certain data and put it in those attributes or metadata. Well, I put it in that metadata, and once I did that extract, I have that data available for me to write code against. So here's the message channel it came on. Here's the URL to download the image. I have all that, and I can pass that on and use that. Here I'm looking to see if it's someone asking about air quality, because I have another demo. When someone asks a question, what's the air quality in a city? I pull that in and process that because I've got something reading air quality data. Here, if it's an image, there's a little extra work because I got to take that URL and download it using an authorization token from Slack so that I have access to it. Here, if it's a PDF and I want to do some AI against it, I'll send it one way. If it's an image, I will send it out to images, and those are those images waiting there. I got 2 cat pictures. And these are a couple of my custom Python scripts, which I'll show you. Not much in here, but what makes it cool is just writing that little bit of Python. Now I have something that looks no different from any of the off-the-shelf processors here, which there is a ton of them, for doing, Amazon cloud stuff or Google cloud stuff or databases or, most of the different projects out there, I can push. Do we still have HBase on that one? I think we took that one out of the main one. There's a lot of extra processors because of the size of the Java ones. We don't include them in default downloads. But things like AMQP, most of the messaging types, obviously Kafka is our buddy. So we run this, and so the images went through the system already, so I could see what happened on this first step. Again, with that metadata, I could see what I did. So it looked at the picture and put in some labels and put in some scoring on, what level of emotion was for that first one. And then the next one we do captioning. This one's a little more interesting. We'll see what it thinks of our cat picture here. There's a cat that is flying over a city street. That seems like that's not going to be a real caption. Maybe AI screwed up. Well, again, like I told you, I didn't change that image. So, okay, maybe that's true. The background is AI. That is my real cat I put in there. He is not flying, and he is not that big. He's pretty big, but he has not stepped on any cars yet. Give him time. And then we run the next one, and then here I take the results. Since you asked and uploaded that picture in Slack, I figured I'll send it out to you in Slack. And we could format Slack stuff. Slack doesn't have really good formatting. But I put some debug stuff in there and all the stuff we captured, as well as putting the image in there. So we got those results. I send them to Slack. That one's off the shelf one. And let it upload to Slack. Let's see if it finished loading. Okay, it did it. It won't do it while you're watching. Doesn't like that. So there's my 2 results. There was that first cat I uploaded, and I put in all the metadata and all those results. But you could format that any way you want. You could also thread it. So if someone asked a question, you could reply to it, and you could call AI or do whatever you want to do. And this one, it's describing this picture. Cat laying on a keyboard. Yes, he was sitting on my keyboard, which is why this talk is this bad. He erased all the good stuff, man, these cats. And then same thing for that next image. Just really easy to do that, but those were all custom processors. Over here I got some other ones just to show you the art of the possible with these. It's really any library. So like here I'm using Faker. I don't know if people are Python people. There's a Faker library that lets you generate fake data, which is helpful. Here is, it didn't change the original data coming in, which was just some bogus JSON. It put everything in the attributes. Again, that's a choice you can make. you can put your output of your Python in attribute metadata, or you could change the actual data there. Because for some of these I want to chain them, I keep that original data the same and just add the extra stuff into the outside envelope so that I can put it together later if I want it to look different. It's just something you could do pretty easy. And then here I've got another processor I wrote to extract entities. And instead of working on a flow file, I let you create your own stuff out of attributes. Make it pretty simple. How much time we got? I still got like 10 minutes? 20 minutes. Oh, okay. So we got a lot of extra demo we could show. That's great. So there I'm just going to extract, and right now it's running. This extract entities one is a little more intense. If I show you the code on that one, where do I have the code on that one? I opened a window, but now try to find a window with 20 things open. Okay, so that is over here. So extract entities, we could take a look at that one. Again, all these pretty straightforward because you just take, if you wrote something in Python already, move it over. The only things you got to think of are, where you putting this stuff. This one I'm using Spacey, which is a pretty good textual library. And I'm accepting that parsing text as my input. I said make sure it's not empty. There's a lot of validations you could do if you want, like, oh, this has to be a number. This one, I just want you to put it in there because why am I running this if you're not doing it? So we extract that attribute over here. I load the correct library for Spacey, run NLP parse on it, and that will extract any entities in there. I mean, it's not perfect, but it's pretty good. So it'll pull out any organizations, date, people, money. And I was thinking I could make it so you could pick, but I was lazy. But if you wanted to take this and fork it and do your own, you could do that. And then I just return those all as attributes, say success, and give you back that original data you gave in for the input. Obviously, you could add a lot of error handling. You can have it decide if you want to have one or two options. You could even do things like, do I want things to run faster or slower? Spacey library is pretty quick. There's some others on Hugging Face, and you could say, hey, do you want the fast entity resolution or you want one that takes longer? Whatever you wanted to add to the code is pretty simple to do. Ooh, I got an error on one. Let's see what happened here on extract company names. So let's take a look at this one. Let's see what attributes. Didn't find anything in there. Oh, it found an organization because we pulled data out of from Faker. So not great at extracting data from that example. It's better if I put something into Slack and have it as my input. It's a pretty easy way to test things too. So I'm curious what error happened here. Oh, that could be coding error. I wonder if I broke something there. Let's go behind the curtain here and take a look at the source code for extract company name. Again, none of the code here is super fabulous, but just to give you an idea how you can, which one am I using? Probably using the broken one. So this one is using transformers, Spacey, and PyTorch. And I'm using a relatively good model there with Berta. There's some newer ones. I probably should update this one to use a different model. Because obviously it failed on something. It could fail because maybe the file was too small or they changed the library. This is one where I probably should have that as a parameter. Good design options to make sure things don't break because you didn't think to have the right thing there. Ooh, are they all failing? Oh, I don't like that. Well, here is why NiFi does something other people don't do. So that guy's broken. So instead, we'll forget about that guy. Then that guy was never there. We never used that guy. We'll just move the live stream somewhere else. Now we have these ones that are sitting in a queue, the ones that failed. Now I could send them to another processor that retries, or just sends an alert, pushes it to Slack, whatever. If we're really we're lazy, so we'll just grab it and we'll pretend that didn't fail, and we'll just send it to the next one to process. Now, should you do that in production? I could tell you when it was originally designed, that was one of the reasons why they had this. Because say something is live happening around the world with a real life event, and someone's network goes down, someone's database goes down, an asset maybe is destroyed, and you can't use it anymore, being able to just pick it up and move it. Now, it doesn't have to be a person dragging that. That can be automated to move that automatically. Or you could write your code better, like I didn't, to handle that and go, hey, if I fail 3 times, like we have this processor here that makes that really easy, and that is the retry flow file. And this will let you decide how many times you want to try something. If it fails, what do you want it to do? So we can go on to something else, like, oops, that thing doesn't exist anymore. Do something else. I usually do that when I'm trying to save to a database, because I usually really want to save to the database. And if I can't, maybe I'll just drop it into the file system. Maybe I'll push it into Kafka to try again later. Or maybe, send that to someone else to try. Whether that's, a Spark app, Kafka streams, whatever it is, in case, we got another one failing. Oh, 2 made it. 2 made it. I think the stuff going through Faker, the rest of them want real data. Because this is to parse addresses, which came in handy because I have a demo not used today. It may be in a later session that you type in where you are, and I parse your address, and I use that to call... I have something that reads the local transit system and tell you these are the 5 nearest buses near you. So I need to parse out addresses, and there's not a lot of good ways to parse out addresses. We didn't have that built into NiFi yet, though David's adding that to the list. We should have that. But we could just call a SQL and use some company code. But to do that for the free and an open source, I'm just using... too many libraries. Which ones am I using here? This one is the PYAP one. I don't remember which one that is. There are not a lot of good open source address parsing libraries. There's a couple, and I try them all, and they sometimes work, sometimes don't work. So this one tries to find, addresses in the text you sent through, and then processes them. Some of them didn't make it. Again, if we wanted all this data to go to the next step, I could just pass it along. Or here I just have it sitting in a funnel. I could direct that funnel somewhere else, and then they'll all move over here. It gets kind of silly what you could do with stuff. I can add a sub-processing here. And this will be magic thing that fixes all my problems. And I'll go in here and just have Tim Junk. And then I'll magically fix it. How do I magically fix it? What's a good option? Delete. No, store it somewhere. We'll just put it into a file. And then that's Tim's problem tomorrow. And it's not Tim's problem today. So I could just take that in here, connect that to... hold on. Connect that to the processor and just have it come in. Do we not have any in there? Yeah, 2 input. Yeah, let me pick it. Tim's junk. So now that's Tim's junk problem, not my problem. And, someone tomorrow can fix that. And then that's, off the screen, and I don't have to worry about it. So I like that. The rest of them will send to Slack. so that we get the results of those two good guys. Whatever they did was better, I guess. What did we get out of their results? Where am I? No addresses. That one didn't do a good job. What are you going to do? But the nice thing is, didn't crash, didn't break anything. Everything's isolated. Just because I screwed up over here doesn't, this is, I had a Python error in there. I should look at the log and see how I broke stuff. We keep a bulletin of all the stuff in there. Oh, they changed the library. Occasionally they update Python libraries, and you could write a NiFi thing to watch pip and see if libraries change, and then when they do, automatically update that Python script. But that's a lot of work, so I didn't do that. Should I do that? No. David should do that.
Or can you just pin your dependencies?
Yeah. I don't know what I did wrong in there. I probably didn't. Or it's just bad coding. It could have, or the data was null. I mean, just a guess.
If they change their API, pinning the library should.
It should be okay, yeah, and it usually is. So it's probably just some other screw up of mine. Maybe something tied to an older version of Python, because I moved this a couple days ago from 2.4 to 2.5, right before a conference where I was going to do it live. I mean, what's wrong with that? I mean, it sounded good at the time. I'm like, no one's going to show up. It doesn't matter. Of course, people showed up. What are you going to do? This is the one AI wrote, which of course never crashes. Thanks, AI. Taking our jobs. Okay. Well, because they write better code, man. Because I checked their code. Because I just did it a week ago. And did it work? Let's see. Come on. Who's better, human or AI? Crap, AI. They had a really easy one, though. Theirs was easier than mine. Mine is calling all kind of libraries. Theirs, but they wrote all this nice documentation for me. So thank you, Cursor. But their one is pretty simple. This one, I mean, you don't really need this one because NiFi can call REST and can convert RSS, which is a form of XML, into JSON already. And I've got other programs doing it, but I was trying to think a couple days ago what would be a simple new processor to do. So this one, so it takes in that URL, so whatever RSS you want to get, parses it. It was pretty smart. There are a couple of variants in here. There's multiple versions of RSS, and it handles that correctly. It also puts some error handling in there, which is a good idea. Also checks to see if things are there, and returns everything as attributes after it is done. Also, if it gets exceptions, it returns errors. Again, I'm going to probably use them to make my code a little better there. So I don't know if that's good or bad, but yeah, so this got, it puts those attributes in there, and it also give us the content back, which is the calls here. I wanted it outputted as CSV for no random reason. NiFi has the ability to take any semi-structured type and turn it to another, so I didn't need to do this. I could have just returned it as whatever, but I thought as an extra step there, I'll put it as CSV. And so it built the CSV file from the RSS. If you haven't seen RSS here, this one's the one for travel advisories. This is RSS, it's just XML, but it did it for me. So it's kind of a useful little processor, because that is one of the sources of data I'm using for one of the later talks. So using our record processor, I read the CSV in and convert it to JSON, because I don't like CSV. But I could have just made the processor convert it into JSON and not have that extra step. But I was like, oh, I don't have anything that writes CSV, let's do that. But we've got processors that do a lot of different formats, which is one of the nice things here. If you look, nowhere in here am I specifying all those field names. It just knows. It'll infer it, or it can use a ton of different schema registries, which they keep adding more. We got glue in there. There's a ton of them. Even using tables. I've done this in Postgres where I point to the Postgres table that it's going to go into and have it auto-validate that the fields are the right names and the right types. And it'll let you say, do you want it to match case or not? You know, it is very flexible there. Here I did some really complex SQL on it because I couldn't think of anything. But what's nice here is with this processor, I can look at one type of semi-structured data, write a SQL query against it, and use that to transform into another one. So, and I can have as many queries as I want here, doing different ways to send my data to wherever it's going. And if, you know, I wanted to do a different one, I can use a ton of different processors here. So if I wanted to do a reader for, you know, Avro, CEF, there's CSV, Excel. Grok is cool, so you could grok things like log files, which are a pain to work with. If you've used Grok before, it's a nice way to parse logs. So I can use that to parse in input and then output it to JSON or Avro. Or let's see what other writers we have. They keep adding more there. I can write it back to CSV, send it to email. What's another good one? XML. I don't know why you want to write XML. I'm sure someone wants to write XML. I don't want to write XML. And then I add some extra metadata here that gives me the topic because I'm going to merge it together, and then here I'm pushing it into a database. I won't say whose database, but it's iceberg tables sitting somewhere. And if you look here, I read that JSON in, do an insert into my iceberg table, the travel advisories. I have dbeaver here and open source tool to run queries. So I'll take a look at the table here. This is just a simple iceberg table sitting in S3 compatible storage somewhere, just strings. And we're just pushing that, what originally was RSS, into this database. And in no way do I have to type in the field names if they change. Doesn't really matter to me. We got some options here if you're going to want to get rid of underscores. Or, you know, maybe you're worried they're going to add new fields to that API. We could just ignore them, you know. But we could also fail if they're not and then send a message to someone to go, hey, you got to change the API, or this one is going to miss this field, you know, whatever you have there. And again, like everything else, I like to debug by sending it to Slack so that it's, you know, and this is also where I like to send errors, so I can have an error channel in Slack that gets all my NiFi bugs, again, not crashing anything, nothing dying, you know, pretty straightforward to do that, you know, whatever you have there. Is there any other cool processors I got in here? Let's see. I think I went through most of the examples. We have a little bit of time where we're pretty close. 3 minutes. Questions or things you want to see? Or we'll just do more random uploading cat pictures. Get the internet appropriate content going. This is just very straightforward, so I know no one has questions. Okay. So we'll upload one more picture. What I should do is take a picture of everyone here and upload it, but we won't do that. Because there's people here who may have are hiding from something. And coming from New Jersey, I respect that. That's okay. I don't know what picture this is. Let's see what I'm uploading. Am I doing it in the right place? Nope. I'm only listening to certain channels in NiFi because otherwise I didn't know this when I started, and I'm automatically having NiFi post to a channel, and then I had NiFi read that channel, and then it went through, and then I posted into the Slack channel. And you can get limited by Slack for pushing in too much stuff. Yeah. And NiFi don't care. I was like, that's what you want to do? Sure. I mean, it just kept running, and I was doing something else, wasn't looking at it. And I'm like, why is there 5,000 new Slack messages? I'm like, oh. Now, it only matters when you do something to somebody who's mad at you for doing that. I had something that grabbed pictures from a place and sent them to Imager. Well, I didn't realize how many pictures there were that I wanted to transfer, and it was a few 100,000. And Imager doesn't, NiFi is very fast in making network calls. So I was pushing something like 500 images a second to Imager. with a free account, so I cannot use Imager anymore. Lessons learned when you're debugging. That is one of the reasons why in NiFi we have things like limiting on things, controlling your settings, putting delays in there. Like I could slow my code down, and sometimes I'll do that because certain databases don't want me to push too fast. So I could say only run every 10 seconds, not run as fast as you can, only run on one server, only run one concurrent task. I mean, sometimes I might want to run on just one node. Like if I'm reading from an SFTP server, don't have 100 nodes of a server trying to read from the same one at the same time. That's okay with things like Kafka where it can have their own partition, but things like SFTP or trying to read something that's slow like, say, a commercial database, we're too fast for that. Anything else in here interesting? I think we are out of time. I want to give the next speaker time to do their stuff. I will have 2 more talks today. One of them is on real-time, real-time NiFi, and the other is utilizing real-time transit. I do some stuff with GTFS that I wrote a custom processor for. That one's pretty cool. They're at 3 and 4 somewhere in one of the smaller rooms. Thank you. And I got some stickers on that chair if you want. No one's going to pay for me to go there, so I turned it down.
Oh, we would have actually covered you that.
Yeah, I mean, that I didn't know. This was a while ago. Because I'm not supposed to be doing conference talks because I am an SE.
Okay.
We're very strict here. Though I'm speaking at on a world tour in New York.
Okay.
Though surprisingly on Iceberg. Which he
Okay.
was not happy about. I'm like, I put in to talk for NiFi and we had someone else for that. So they like, oh, we got a spot. You want to do that one? I'm like, I guess. Why not? That is fun too.
Not to give an SE a microphone.
Hey, I got a good demo account, man. I will keep going. Oh man, did I not turn it off?